Hello, everyone. Welcome to episode 3, the peer-to-peer network. Um, so today we're going to be working at we're going to review part of the code of the network, continue the work that we were doing in episode 2, and also see if we can implement some suggestions from the guys of the desktop app. Okay, so let's get into the code. Okay, here we are. So this is our stack. This is where we start. Um, in fact, this is coming first, then this. We'll not need this for now. And then we were looking at this guy the other day. This guy, let's put a little bit of order here. So we have network and we have social trading. Okay. So one of the things that I would like to do at some point in time is to allow what we call a network node to run different services, because I can begin to see I am beginning to see that there might be more than one service provided by the network nodes, and probably social trading is one of them. Social trading might be one of them. But then you have the signal distribution that is kind of the same, but not exactly, because one thing is the distribution of signals for social trading bots, and the other thing is distribution of signals for people trading together. Okay, so there might be something there. I'm not going to worry too much about that right now. We're going to continue cleaning this and trying to put it in order. So this is the right stack. Here is the starting script, the launch script. This is the root where we load dependencies. This is looking good. And this is what represent the network node. Let's call it app or something like this itself, right? So here is where we have these two functions. One is to set up the network and then set up services. And by services, we are meaning the Websocket interface and the HTTP interface, where messages are coming into this node. There is also some storage service that allows the node to be recording everything it does and sending it to a GitHub repository for now. That is also something that is pending, in the sense that that mechanism might need to be upgraded, especially with this concept of open storage, where user can select which storage they want. So far used for trading signals, but have not been extended to everywhere. Okay, but let's go in order here. We've seen this, that here we store an object that represents our own network node. Okay. And inside that we have a reference to the node that we define at the governance system representing this network node, and a few other things like our network identity. Okay, so that's good. Let me clear this. Peer-to-peer network. Okay. So this network node, peer-to-peer network node, where is this? What is this guy? Then we were also cleaning a little bit this, what we end up calling the bootstrapping process, the APP bootstrapping process. This is a process that is needed by anyone using the peer-to-peer network because it loads into memory the several stuff like the app schema files of all nodes. It loads also all the plugin profiles in memory. It scans the plugin profile and extracts from there the network nodes and the sign-in accounts and many things that are needed later. So it's like a bootstrapping process that is going to later be used by other mechanisms embedded into this node. So this search function is really working very slow today, but I still want to have here that stuff. So this is the bootstrapping process. We put some order into this. We know that we are missing the calculation of the rankings, okay? But at least these have some order now. These are not profile. We're going to continue improving a little bit. Plugin or load user profile plugins. Okay, that is exactly what it's doing. Use loading user profile plugins, and here all this code can also be a little bit more tidy. We will put it into function just to make it clear. So function load Um, this is an important part of this code, is where we I don't know if that comment is really useful. So set up network client identity. Okay, this is very important because every entity accessing the peer-to-peer network is a network client, and they need to have an identity which other recognize, and an identity is essentially a signing account, an account which they are going to use to sign their messages and by which they can be recognized at any place across the network. Okay, so this function in particular, what it's doing is to, based on the information at the environment file, is using the configuration of the environment file to know which is the code name of the application that we want to be running. Let me explain in more clear terms. Let's say you have defined 3 peer-to-peer network nodes at your user profile at the governance system. Okay, when you run a network node, how the program is going to know which of the 3 you are trying to run? The answer is the one that you define at the environment file. Okay, so at the environment file you will say, here I am running peer-to-peer network node number 2, and that comes here. Okay, that's come here. So with that information we get from the secrets file, we will get the node ID at the governance system of the peer-to-peer network node number 2. Okay, so when we find, because here we are scanning each user profile nodes, so when we find a network client ID that matches the one at the secret file, then that means that we have found our network client identity and we are storing it in here so that we can then sign messages with that signing account. Okay, that is what is going on here. It's very important, only 3 lines of code, but very important stuff. So let me try to put that here as an explanation. Mm. Okay, so it's better than before, and it's what I just explained. Okay, this is very important stuff. What else will we have here? Here we are. Here we are. Okay, this function is about function. We are loading or load. So another thing we need to do is to load into memory and have it classify there which are all the network nodes available in existence. That means define it at any profile of whoever, because then we will need to connect. We will need that information to connect to those nodes. So at this bootstrapping process, we are just discovering which are the nodes and loading them, classifying them, because we are reading all the user profiles. So part of what we need to do is that pick up all the nodes and remember them. Okay, and yeah, so here we are loading all sign-in accounts. Okay, so we are scanning all profiles. Function load signing account. As we are as we are as we are scanning all the profiles from each profile, we are extracting all the sign-in accounts and making an inventory of them. Okay, and some of the sign-in accounts belongs to network nodes. That's why we are also creating an inventory of network node. And one of the sign-in accounts of all the sign-in accounts in all profile is going to be our network client identity. Okay, that's how everything is tied together. So let's put this in here. And we are going to also add a comment here, because everything happening here is important. Um, for we Remember that a peer-to-peer node is also a network client, okay? It's also a network client because it connects to other nodes. So in a way, it's also a network client. Okay, so now we have this a little bit more, a little bit better. Okay, these are this is important stuff, but also we can run it in sequence and not need to put it in functions. Just the way of the reason of putting this in function in this case is just to see it more organized and more clearly. Okay. So for me, it's easier to see things like this, even if it is a function that is going to be executed only once, because I know what is going on. Then, okay, I know what is going on. And we can see the code in a much more clear way. Okay, so these have a little bit more order now. I'm going to run it to see if it's still working. Not really. So, okay, there is a continue. Probably is it need to be turned into a return because now this is inside a function and we want this to loop again. So this will be return. This will be return. So we go again. Okay. So it seems to be working. So we process this. Um, okay, so my query here is still not working. The search is, I don't know why it's not working. So I'm going to come back in here. Forget about this. What I was looking was just here. We saw this at the previous episode. This is a small module where we are storing our own identity that represents the network node that we are running. So far is this small. Okay, so we store the blockchain account, the node, the peer-to-peer network node that we had at the governance system, the user social profile, and that's it. And the peer-to-peer Client identity is a very similar stuff, but this is usually um, used by application like desktop tax server and these kind of guys. Okay, so we are here. We cleaned this stuff, and now we understand what we are doing here. Okay, here we are just instantiating this, passing it here, where we are setting up a lot of stuff in memory, but also we are initializing this guy and putting our own identity there. So we are here. The next thing that is going on is that it says here, let's discover who is at the peer-to-peer network. Okay, so we have the bootstrapping process, we got it. This guy, we got it. And this guy, we got it. What I'm not sure is, okay, let me find something again. Bootstrapping process. Mm, okay, we are here. Says new network node, peer-to-peer network. Okay, peer-to-peer network. It must be this guy. So this module represents the peer-to-peer network is needed to enable the connection of this current node to other peers. The main feature here is the array of nodes that we can potentially connect to. We are running with the when we are running with the role of a network peer, the list of our node will include ourselves. Okay, so this is a small module that holds an array of peer-to-peer network nodes to connect. Okay, nodes to connect. Okay, so when we are a network node, and in this case we call it network peer. Okay, we are in this current version we can connect to any other network node except ourselves. Okay, except ourselves. When we are a network client, any node is open for connections. That's current version. Okay, this is probably where we are going to be working also down this series of episodes, because we are going to restrict the connection of nodes based on the token power or ranking of the nodes. Okay, so the place to do this is here. Who we can connect to is going to be defined in this model. So far it's simple, but it's going to evolve a little bit. Okay. Okay. So we have a peer-to-peer network the array of nodes that we can connect to. And this is what we are setting up here. So a better explanation is that one. Then we have set up the connection to network nodes. Okay, so this module is just about which are the possible network nodes we can connect to. And this other network node is about, or most likely about, actually connecting to the peers. So let's see what it says. This module holds the peer-to-peer nodes we are connected to. Okay. So this means that this module knows who we are connected to and is the one actively seeking to be connected to other nodes. Here we implement the mechanism to connect via WebSocket to a set of network nodes and keep ourselves connected to them, so that when it is needed we can send message to them, but also we will receive incoming message from them. If connections are lost, we will reestablish them so that to keep ourselves connected to the configured amount of network nodes. When an outgoing message is received, it will be routed to one of our pool of connected nodes. So it's also acting as a router via its send message. So that means that this module, what it does is essentially keep itself connected to other network nodes via WebSockets, and when a message is needed to be sent, and we here remember that this module is used both by any application, not only a network node, but also it can be a desktop app or task server. Everyone is using the same mechanism, right? So when you're going to send a message, you send it to a random node, so far random, a random node of the ones that you are already connected to, okay? And obviously the ones that you can connect to are the ones pre-classified as at the other node, at the other module, where we have the rules of who we can connect to, okay? So it's pre-classified. This is just about running the rules of who we can connect to, and this is actually the one who is establishing a pool of connections and allowing whoever is using this to send message to any of these nodes that we can connect to. Okay, so this is what this is about. So we set up a pool of connections to the network nodes so that later we can send a message to any of them. Okay, so this is what is going on. Okay, and mm, this is the initial setup, what we call set up the network. This is our identity. Okay, now everything is clear. We have this module, create an empty object, pass it here. We have the bootstrapping that do a lot of stuff. Then we create the module that is going to run the rules of who we can connect to. And finally, we set up a pool of connection to different network nodes so that later we can send a message to any of them. Okay? This is what we are doing here. So on the setup services side, okay, we have a service here that is the social graph, okay? But as I was saying, I would like this to run services only if they are configured at the user profile, okay? So this is something that we're going to do, and we're going to do it quite soon after a small review of all this. So to do only if the service configure at, okay. So the social graph service is going to be one of the service a node can have, okay. Okay, so let's get this guy. And take a small look at it. But I'm not sure this is going to work because search is not working today. So we'll go and find it here. Social trading. Might be this guy. Okay, yeah. So this model represents the social graph service that deals with the social graph that this node maintains. The social graph is one of the services the network node provides. This service is responsible for maintaining the whole social graph of relationship between user and bot, and also between their posts. Okay, so the service is doing nothing because the social graph today is implemented as something like is an integral part of the network node, which is really not the case. But um, this is where we will have to work at some point in time during this video series so that the social graph end up being just one more service. Okay, that's why I put it to do there. Okay, then storage. And this is a particular storage of the social graph. It's not the storage of the node itself, because the node so far it has nothing to store about itself, but as a social graph service provider, it needs this storage. Okay, so this might be here, and is, to be honest, is it will be probably better to call it social graph storage. This is incorrect because here there was a confusion, and we were thinking that the social graph is the network node, and that is not really the case. So this represents the social graph physical storage, and it's a memory even to load them when the node is starting. Each node has a GitHub repository to store the social graph. To do, we will need integrate this with open storage project. Okay, so we standardize this. That GitHub repository can be used by any other node to get the history of events that can build the social graph. Wow, this is good, but it's also something to do. To do build the mechanism to retrieve information from other nodes storage. Okay, so what this means is that if you run a node, if you're running the first node of the network, then everything is good because the network is starting with your node. But if you are joining the network later, you will need the history of what happened before to construct your social graph. So you will need to use some other node's history stored somewhere. So that is not really done. And we'll need to solve that problem at some point in time. So I will write it there. Each network node saves locally all unsaved events every 1 minute, and after saving, pushes the changes to its GitHub repo, which acts as a backup itself and also for other new drop their copy of the graph. Okay, this is perfect, but the problem is that it's not really implemented yet. So here, the way this works is that we have, when we initialize, we load events from the storage, from our storage. Essentially, it's a local repository. It's a local repository. And We open the file, we go through all the contents, and because essentially what we have are events recorded there, we just apply these events as if they were being received via the network. Okay? And that's how we build a social graph every time that we start the node. Okay? So this is the way. And to save the events, it happens every 1 minute. What we are doing is that we are going through the array of events that we have in memory, but from the last saved event, we are saving this into a 1 minute events file. And then we do a git push to our repository online, and information gets stored online. So it's kind of simple, but it works. And this is what this module is doing. Okay, so the only thing I would do here is, in fact, I would change the name of this. Even though this is on social trading, so we can assume that this storage is... Okay, I will not change the name for now. So this is what was happening here. Okay, this is what is going on here. If we continue down the road, it says other network nodes and client apps will communicate with this network node via its WebSocket interface. This is where we instantiate it and initialize it. And if it happens to work, the initialization, then we console log this stuff. Other network nodes and client app will communicate with this network node via its HTTP interface. So the HTTP interface, we are using it for now only to receive trading signals. Okay, only to receive trading signals. And the other one, we use it to receive queries and events. Okay, queries and events. So on this guy, we're going to close some stuff. WebSocket interface here. We find it here. It's a more complex stuff, but essentially what it does is this model represents the WebSocket interface of the network node, and the network node is expected to receive a connection request from two different types of entity. Other network nodes, client apps. This model deals with the two connection time and is the one receiving from and sending messages to those entities. So what this means is that this module is the one that is receiving the messages coming via WebSockets from other nodes and client apps. and also is the module that is sending or broadcasting messages to other nodes when needed, okay? Especially by the process that needs to forward information, okay? But only the one that is via WebSockets. On the HTTP side, we have a similar situation here. But this is still the small representative API of the network node. All HTTP requests are processed by this module. So far, we are talking about trading signals, okay? So here is a very big to-do. That is something that we will be doing soon. That is make sure or implement, not make sure, that trading signals are also sent to other nodes, because so far the current implementation is what it's doing is that it's taking the signals and uh, calling the WebSocket interface and telling, look, I got this stuff, send it to everyone you are connected or is connected to you. So that worked and was tested for network clients. They receive the signal. That's good. But what happened to the communication to other nodes? They probably get the signal, but I haven't tested that it's going to be replicated across many nodes until it get into some final destination. So that's something to check. And also something that we need to do is to implement to send only trading signals to the guys that are following the emitter. So this to do is probably not for here, but it's something that we need to solve. Okay, today the signals are sent to everybody. The same happened with the events that are getting into the network. They are being sent to everybody, regardless if you are following them or not. Okay, so that is some of the important things that we need to address in this next iteration of the peer-to-peer network. Okay, so very interesting, a lot of stuff to do. Plus, on top of that, we have the requirements from the desktop guys to add a few queries and things like this. So I will have to pick how to continue from here. My guess is that after this overview, my guess is that the first thing that I would like to do is to fix the stuff at the base layer first and then start going up the stack. Okay, so the base layer is the network layer itself. I mean, the network nodes. So I am starting to believe that the first thing that I should do is to create the create these services at the user interface so that I can have the idea implemented of these services and start separating logically what is social trading kind of stuff with their social graph and all this stuff that should be a very clear layer on top of this. From the networking part that is about peer-to-peer network nodes connected to each other with Websocket interface, HTTP interface, and the distribution of messages based on token power or the ranking of the nodes. So I guess that's is what is coming first. I'm going to configure that and then go through the code, separate the incumbencies well so that we can have a social trading as a service, okay, as a service. Um, then I will probably go and implement the ranking so that the nodes or the services have, I guess the nodes will have a certain ranking because the nodes are the one connected to themselves. Um, and once I have that, I will also check that the distribution of signals is going well through the network. And once I have that, and all my base layer is robust and resilient and trustworthy, then I'm going to move up to the layer of the services. And I'm going to check that the service infrastructure is good. I will need to check that a node can be bootstrapped from other node history. I will need to probably implement the concept of open storage so that the repository to be used is something that the end user can choose and it's not fixed. And once that is working, then I can move even higher to see what is going on with the queries and events. Maybe as suggested, I can return some information after events execution or not, maybe, I don't know. And some other suggestions that I have regarding this. Okay, so it seems that the next thing to do is, so as to keep everything order, is the separation of uh, a more clear separation between the services and the network infrastructure itself. Okay, so that would be the topic of the next video, next episode, and this is where we finish today. with a review of what we had, some cleaning and ordering, and getting ready for a bigger intervention in the next one. Okay, so thank you for watching. See you next time. Bye.